Hi, welcome to our math. Today I'm doing a series of videos on solving exponential equations. So I'm going to show you a few different approaches on a few different problems. Sometimes I'm going to give you one approach. For all of these, we're going to round to 3 decimal places as applicable. So when we have e, the inverse of e is natural log. So if we take the natural log of both sides, natural log of e to the x, natural log of 267, because they're inverses there and back again, if you take e to the x and the natural log of that answer, what ends up happening is you end up with x. That's what an inverse is. Inverse, if you do something and then you do the inverse, you're back where you started. And the natural log of 267, if we put that in a calculator, we get 5.5872, which rounds to 5.587 because that 2 is less than 5, and so we just truncate it. For my next problem, if I have a number that is not e, I have 2 ways of solving it, and I will solve each of these 2 problems that are not e differently. Actually, I'll do these 2 differently. The way I normally do these is logs are exponents, which means if I take the log of both sides, I write log of 27 to the x equals log of 5,416,800. What ends up happening is there's this thing called a power rule, which allows me to take this x and drag it out front. So this really becomes x times log of 27, which is one of the reasons we really like logs, is because it allows us to ground exponents. Exponents are counters, counting how many times you multiply a number to itself. But when you use a log with an exponent, you make that number, that exponent, a real number. Then I can just divide by log of 27. And I throw this all into my calculator, of course, and I'm going to get that x is equal to 4.7044. So I'm going to have x is equal to 4.704 once I've rounded it. So I will show you that way again in case you missed part of it. You take the log of both sides. Log of 0.7 to the x equals log of 12.33. If these are equal, then the log of the arguments are equal. As long as you're doing the same thing to both sides, you can't take the log of one side without doing it to the other. You have to stay balanced. The power rule says that the x can travel out front as a multiplier. X times log of 0.7 equals log of 12.33. And then we can divide by log of 0.7. And I get that x is equal to negative 7.0429, which rounds to negative 7.043 because 9 is greater than 5. Okay, but I said there was another way of doing these. Some people really like using the inverse. And the inverse of e is natural log. The inverse of 15 to the power is log base 15. So logs are exponents. So whenever I rewrite something as an exponent, I start with the exponent. Exponent equals. That way I know where everything else falls. Log, but it's not log base 10. We've been using log base 10 here. It's log base 15, 0.15. And then this is the argument. And what a log answers is the question 0.15 to what power equals your argument. Very literally what this problem states. All right, now some of you have a handy dandy button in your calculator that you can just plug that into your calculator. Most people don't. Well, to calculate this, you have 2 buttons on your calculator. Natural log, that's not an IN, it's an LN, log natural, LN, and LOG. LN is base E. LOG is base 10. If you look right above the button, you'll see that because above the log button, you'll see a 10 to the x, and above the natural log, you'll see e to the x. But this is neither natural log or log base 10. So the change of base tells us that you do the log of the argument, the 0.003375, divided by the log of the base goes to the bottom, log of 0.15, you'll notice that it's exactly the same thing either way you do it. Either you use the power rule and divide, or you use the change of base, but you're doing the same calculation in about the same number of steps, which is why it really doesn't matter your approach. In this case, my answer is going to be 3, which I don't need to round because it's just 3. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!